Okay, this first one, structural and geometric. How are these two guys different from each other? Are you okay with me saying that the structural isomers, they're actually connected differently? And then, so how do you describe the geometric?
Same chemical formula, different structure?
Nope, that's structure.
Oh, structure, sorry, thank you.
It's got multiple bonds, so there's no spin. So chemically, it could say the same amount or have the same molecules, but.
They run with this in the trans.
Are we okay with that? They're connected to the same atoms, the cis and the trans. It's just that they're arranged differently in those connections. But you're right, it's just cis and trans that we're talking about, and we're only really talking about double bonds. So that's where it's focused at. It's just that it's their arrangement in 3D space, in geometric space, that lets them be different than each other, from each other, even though they're still connected to the same atoms. Draw to structural and then to geometric. All right, so let me do that. Two. Dimethyl butane and 2,3 dimethyl butane. And geometric ones can just go so these two are both 1,2 dichloroethene, and then this is my trans, and then this is my cis version. Okay, so let's go ahead and draw this hexadiene. All right, so I've got 2, 3, 4, 5, 6. So there's my hex. And then my diene, I need to put double bonds on 2 different sets of atoms. So I've got a double bond going from 2 to 3. And then I got another one going from 3 to 2. Sorry, 3 to 4. So far I've taken care of the hex and I've taken care of the diene. Now I need to manage these chloros. So there's supposed to be 3 chlorines on carbon number 3 and then 2 of them on carbon number 4. So I'll put a chlorine right there, and then I'll put a chlorine right there, and then another chlorine right there. We good with that?
Is that carbon showing 5 bonds?
That's the problem. So I want you guys to be able to draw this and then recognize that, hey, this is a problem. How many bonds are there? 5 bonds, not a problem, not possible. Right here, also 5 bonds. So neither of these two things can occur. Answer the rest of this question, I would just say this one here is sp3, and this one is sp2, this one is sp3, and this one is sp2, and those other two can't do anything with those since they got 5 bonds.
Is that an SP?
Huh?
Well, there's 3 three bonds can have
Oh.
one carbon there. No. So, yes.
There we go. We're gonna name everything in this table, okay? So I've got 1, 2, 3, 4, 5. So I've got 2. What in the hell is that? 2 pentene. That does work. No, sorry, there's a chlorine there. My bad. 1, 2, 3. So 3 chloral, 2 pentene. Better? No?
Is there a method for there? So we have 3 chloro, 2 methyl, 2.
I don't know what these things are doing. Awesome. There's something there, right? No? Okay. Why isn't this table coming up? One, 2, 3. Yay. How am I gonna fix that? I think I just need to get rid of the tables. So 3 chloro, 2 methyl, 2 pentene. Does that work? 1, 2, 3. 1, 2, 3, 4, 5, 6. So cis. Three, 4 dimethyl hexane. No. 2 hexene. That one work? What's wrong?
Well, I'm confused.
With which one? What?
Then it's this part, I guess.
Okay. Same thing on the double bond, right?
Oh, I thought, okay.
Across that double bond.
Mhm.
So methyl, hydrogen, methyl, alkane chain. Since the double bond's got the same same thing on both. So then I've got the cis transit, right? Because this methyl group could have been on the other side. Remember that? You don't look happy, Jeff. You still don't look happy. What's wrong?
I guess I'm just not seeing it, but
Okay, so you see a double bond. You should say to yourself, let's make sure that this isn't cis or trans. Okay. So you can eliminate cis or trans if on either one of the 2 carbons that's a part of the double bond, what would eliminate any cis or trans? If on one side of the double bond, the 2 things that were there were identical, then there's no cis or trans possibility, right? If
so because that line is going in the same direction as the other methyl group, because it's on that side, is that what the line structure is telling us?
What?
Because I wouldn't count that as a methyl group because it's part of the chain, isn't it?
Doesn't
Or the
matter.
hexane group.
The methyl group is,
It's a methyl.
I see what you're saying, that because it's the chain, well, I'm not gonna count it as a side chain. That's not the issue. This is 6 carbons in a row, right? With those, this 6th carbon here could have gone that direction.
Right, okay.
That is really gonna piss me off. Maybe I can just. Let's see if that works. Okay, so since this can go that direction, then it has the possibility to be a cis or trans.
So, next time if I see this diagram and that line goes the other way, it's a trans.
Correct.
Okay.
But what your job to do when you see this, so you see this double bond right here, you identify what's right here and what's right here and what's right here and what's right there. Okay? So I've got an H, a methyl, and an alkane group. Good so far? If on this side of the double bond over here, the things are different, and I've got a hydrogen and a methyl group there, and on this side of the double bond, the things are different, and they are, then cis or trans is a possibility. If either one of these, if this carbon right here or this carbon right here have exactly the same thing of going up and down, then it can't be possibly cis or trans.
Can you show us one of those?
Sure. I think right there. So carbon number 2, we have carbon number 2. So that's carbon number 2. That carbon number 2's bond, that double bond, what's coming off of the double bond on that side, on carbon number 2? Not 2 H's,
Two methyl
2 methyl
group.
groups. This guy right here has a methyl group going this direction and a methyl group going that direction.
Okay.
Wow.
Can you just draw it on the board?
Yeah, I'm gonna just draw it on the board. Are we okay with that being the structure? Okay. These are not the same thing. These are not the same thing. Could be cis or trans. So how do I know if it's cis or trans or not? Is there something over here that's the same as something over here? Yes. The CH3s. We are identifying the cis or transness of this double bond. Forget about the fact that it's in a long chain, okay? This carbon right here and this carbon right here are dictating cis or trans. The reason that they're dictating cis or trans is because this 6 carbons in a row, the carbon doesn't have to be down there. That could be an H. And this could be a CH3 up here. Sorry. And then there's an H there. So did I change the connectivity of anything? Everything is still, all the atoms are still connected to the same atoms. But I did change their arrangement in 3D space, right? So now these 2 guys are what to each other? Trans. And before they were,
Cis.
so this one here is,
Cis.
and so how would this be drawn differently to be trans? This line right here would be going up and there would be no line right there. Happy with that? Okay, this next one? Fluoroethene, right? Yeah. Do I need to write 1 or anything like that? For the location of the double bond or for the location of the fluorine? It's only 2 carbons, it doesn't matter. Okay, and you okay with that? Triple bond can't have 2 things coming off the other, because what's the hybridization of this carbon that's got a triple bond on it? SP, so it doesn't have any more bonds to make other than 2.
What did you write there, Andy?
Not possible. All right, so I'm going to draw everything in this table. What I'm going to do is so
When you say draw, I don't know if you want like a line drawing.
don't care. If I say draw, you can do whatever you're most comfortable with. If I specifically said draw a line drawing, then I would want a line drawing. So unless it's specified, then you can draw however, whatever you're happy with. Is that it? We good with that? 1, 2 trans, yeah. 2, 3 hexadiene. So 2, 3, 4, 5, 6. And then propene. And then 2, 3, 4. So that last one, super important that you have that little hitch thing there.
Or a line with BR, right? To indicate that it's bromine.
Yeah, that's what I'm saying. This line has to be here, right? If that line's not there, then it looks like it's 3 carbons connected to a bromine. So make sure you've got 4 atoms for your bute, and then draw a line from that 4th carbon to your in this case, bromine. Oh, all right, that's it.